Karthik? Karthik?
Sir, am I audible?
Yes, sir. Yes. You are audible actually. Okay, we can start the session.
Yes, sir. I am starting, sir.
Okay.
Thank you. Very good morning, all. I am Karthik Reddy, a PhD research scholar at the Department of Electrical Engineering, National Institute of Technology, Rourkela. Welcome you all for the Day 5, Session 1 of a National Mission on Power Electronics Technology, NAMPET-sponsored online short-term course on Power Electronics Converters applications in microgrid and vehicular technology from 20th July to 24th July 2022. Organized by the Department of Electrical Engineering, National Institute of Technology, Rourkela, Odisha, India. It's my pleasure to introduce our speaker, Dr. Aman, who is going to deliver his talk on gallium nitride device application for power conversion products. Dr. Aman is working with Havells Noida campus since June 2021 as a General Manager, Research and Development, Lighting Electronics in Corporate Research and Innovation Department. In current role, he is associated with the power converter design for LED driver, which are applicable for home lighting, street lighting, solar LED lighting, and smart lighting. He has completed a PhD from Indian Institute of Technology, Delhi in 2017 and MTech from Indian Institute of Technology, Bombay in 2005 in power electronics and electric machine control area. He has total 15 years of industrial experience on smart switching mode power supply, AC to DC and DC to DC power converter, product design, control system, stability analysis, automation, industrialization, power quality, high frequency magnetics, electromagnetic interference, semiconductor power devices, and component selection, active as well as passive devices. He was associated with other reputed industry as a designer as well as managerial roles or ST Microelectronics from 2015 to 2020, Barco Electronics from 2010 to 2015, Allegro Microsystems from 2008 to 2010, and Delta Electronics from 2005 to 2008 in power conversion domain. Other voluntary as a reviewer of reputed journals, technical speaker of reputed forums, faculty development schemes trainer, senior member IEEE, and visiting professor at NIT University. He has more than 56 reputed research publications in IEEE and equivalent journals and several free designs available on the different technical forum. I welcome you, sir, once again for the session. Over to you, sir. Thank you. Sir, your audio is not audible, sir. Please switch on.
Is it okay now?
Yes, sir.
Yes, sir. It is okay.
Yeah.
Good morning,
Yeah,
sir.
Karthik. Good morning. Hope I'm audible and visible to everyone.
Yes, sir.
Yeah.
Yes, sir. Yes.
So thanks, Karthik, for a nice introduction. So it is my pleasure to coming for this topic here in this forum. I think everyone knows the NEMPET is the initiative of the means power electronics from the government of India, and basically I was associated with these events NEMPET from beginning in 2007. So, and I think now the topic is quite changing. Earlier we are discussing on the silicon devices, and now we are in the verge of wideband gap devices in the power conversion applications. So now coming to the quickly on the topic. So just sharing my screen. Hope screen is coming to you, everyone.
Yes, sir. It is coming. Sir.
Yeah. Okay. So now I'm in full screen mode. Is it
Yes,
coming there?
Okay. Yes, sir.
Okay.
Yes, sir.
Good. So thanks to the organizer and this basically the NEMPET and the Venkata is the main source who interacted with me and organized this event.
Thank
And
you.
then yeah, thanks for your means initiative. Now coming to the topic, basically the GAN device application for power conversion products, and it is not now new topic. So here basically if we go to the means the history of the GAN, so basically it is used for the blue LED generation, blue color of LED generation, normally for means uh, blue kind of that blue rays and that diagnostic and that. So the good part of these devices is it has the wide band gap, and slowly we will discuss on this topic here. What are the benefits we are getting for the power electronics using these GAN devices? And later now people are thinking and researchers are thinking we will go with the actual power products application using these kind of devices. Hope I'm audible to everyone and the screen is moving also, slides.
Yes, sir.
Yes, sir.
Okay, good. So this is the discussion for today's. In 2 hour session, we cannot complete all the design benefits and applications, but I have consolidated here around the 4 areas. So first we will discuss about the power electronics application area where the people are talking much. So then the technological breakthrough, what the power electronics engineer are thinking about that. Then we will quickly go to the power devices overview. And the second session will be for the GAN transistors. And here we will discuss about the characteristics, motivations, limitations, equivalent circuits, gate drivers, integrated solutions, package selections. So in this topic, we will focus on mostly on the GAN transistors use case and why it is there. And I have removed the physics of the GAN, basically the VLSI side. So here the mostly focus on the power electronics application kind of things, power conversion applications. Based on that, then we will quickly move to the third session. That will be the benefits of the GAN device using in those kind of power conversion applications. So again, I have highlighted here around 6 areas. That is the hard switching. That was of not much talking point earlier because due to the losses in the switch. So due to the thermal means benefits here, we can run at the higher thermal points. So again, the hard switching can be done where it is needed by using such kind of devices. Then the synchronous converters. Here I have taken the boost converter as an example. So again, we will not go in detail what is the synchronous and that. So just we will discuss the points where we will take the leverage of this kind of technology. Then the soft switching, it is again the new, basically the talking point of the benefit of the GAN or wide bandgap devices. Then adapters, totem pole PFC, LLC resonant converters. These are the examples we will discuss in the third sections. And at last, we will see the actual benefits happening in the places and the products available in the market and where we can get being basically electronics engineers, we should know also the where we can get those devices in the market and we can design our circuits. So these are the last sections. That is basically I have divided in the 4 sections of this topic today. Okay. So hope means audio is okay because I am not able to see other
Yes, sir.
people. Yeah.
Everything is
Okay.
fine.
Yes, sir, it's okay.
Yeah.
Please go.
Audio
Yeah.
is okay.
Okay. So this is the basically 4 sections we will discuss in the 2 hours lectures. And based on these outcomes, we will discuss out of the box and now coming to the first sections. Here, if we see what are the power conversion application areas where we as a power electronics engineers can focus. First I have taken as a means automotive. So I think you know the automotive is quite moving towards power electronic sides. Earlier it is in mostly on the mechanical domain, and now it is due to the EV kind of activity. Now it is moving towards the electronic side. Again, also the electronic components are keep on increasing. So here, as a power electronics engineers, we have a big focus. For example, automotive electronics, EV, HEV, hybrid electric vehicles, basically car audio, infotainment, telemetrics, sensors, automotive sensors, lot more. We cannot put everything at a one place. So this is the area where if we see the market, around 80% of market penetration towards the electronic sides now in automotive domain. So it is also evolving field. We can focus here. Then the computer and office equipments, again, it is a well-known facts. If you see the all the computer manufacturers and chip manufacturer in these domains, here electronics, for example, in power PC, laptops, storage, printing, scanning, UPS, everywhere there is the application of power electronics, and we can focus there and understand, because we cannot do each and everything at a one shot. So being an electronics or power electronics people, we should understand what is the gamut of the in this application area, and we can focus, because whatever we do, it will go to the market and it will go to the field. So a lot of regulation and requirements is there. So we should have to go with the segment wise. So that's the reason I have highlighted the different section here. Then the third is the lighting. Again, if you see the loads, lighting loads is around 11% of the overall consumption of the power, as per the some research forum and regulatory agencies. So here also the power electronics being the semiconductor lighting, I think everyone knows that the LED lighting, and here lighting electronics is again quite moving towards the power electronic sides. That is, I think people know here the LED drivers, the smart lights and all. So here the big chunk of work is available for us to focus here. Again, also I have put here electronic ballast. It is again now in the verge of limitations. But if you see the means UVC lights and all, still it is available. So here again the power electronics play a major role here. Then the consumer electronics, it is the very big chunk of electronics are available there. So video, audio, hi-fi, VCR, iPod, lot of things are there. Digital cameras, televisions, white goods, power tools, AC systems. A lot of things are available in the market, and being engineers and designers, we should focus here. Again, all the industry are driving force are different. For example, if we see the consumer electronics here, the major focus is on the cost perspectives, and at the same time in automotives there is the focus area is on reliability points. So, and coming to the industrial segments, everyone knows around 50 or 60% kind of power processing through the motor controls, UPS, welding, HVAC. So again, industrial in electronics is also play a major role for the power electronics engineers. So we as a engineer, we should focus and understand the gamut of the electronics application areas. Now coming to the medical electronics, again here also diagnostic equipments, portable appliances, imaging, X-ray, MRI, CT scan. Here major focus area, here the technology, electronics point of view, technology is not quite flexible and not changing frequently. But here testing perspectives is a major focus area, and again reliability, again the things, testing and certifications. So medical electronics is another field where as electronics we can focus. Now coming to the transportations, we know the high power electronics like application in trains, ships, vessels, buses, coaches. Energy is again the big area here. You know, the carbon credit and lot of things, carbon emission regulations, lot of things are coming up. So here the windmills, renewable energy is the focus area, solar, other renewable sources, energy transportations and distributions, traditional energy productions, power plants, lot of things. Now, the last, military and aerospace. Again, you know here, simulation play a major role because we cannot experiment in the field. So again, being a simulations, hardware designs, PCB designs, product designs, we should also identify the field of area where as an engineer we can focus. So here also, if we see the aerospace, simulation play a major role because we cannot experiment much here. And again, it is not frequent, electronics not frequent changing here. So longevity of electronics components play a major role in military and aerospace. Telecommunication, if we see here, we know the part very well. Everyone is well known that. So phone, mobile phone, telecom infra, we know the server and all, means telecom tower, we very well know. And we know also the 5G is coming. So again, here the power electronics play a major role. So these are the broadly the different areas. As a engineer, we can focus and understand the technology movements, product movements, market movement, cost perspective, business alignment. So a lot of things we can focus, but fundamentally same everywhere. Being a segmentation is very important. That's why I have made this kind of segmentation here. So now coming through the more consolidation point of view, what are the breakthrough at all the stage we should work on? So three areas basically we know. Just a minute. Pointer, just I'm taking the pointer. So if we see the marketer is more talking about the dollar per kilowatt. In terms of the materials, kilowatt per kg. In terms of the area, applications, kilowatt per liter. These three are the major talking point for a power means engineers these days. So if we discuss on the marketer, they will ask you how much dollar we have to pay per kilowatt kind of or per watt kind of power processing for your product. So material engineers normally they will focus on the how much kilowatt we can process through per kg of the product. So again, transportations and a lot of things is involved here. And if we see the means packaging point of view, so per kilowatt per liters. So these three is the parameter where we can judge our products in the market. So for that, what are the tools available for us as a power electronics engineers? If we basically this is the consolidation here. So as a power conversion architect, we should know what kind of converter topology we are working for, like power factor corrections, low voltage, high voltage, DC-DC converters, AC-DC converters. So here we should understand what as a if we have you have a chance to work as a power conversion architect in a industry, so you have to focus on the topologies, what kind of topology you are going to design your product so that these things can be meet as a outcome. Similarly for the power inversion, DC to AC, AC to AC, matrix converter, GTI grid tri-inverters, UPS. So here the power conversion architecture play a major role in terms of all three. So here if you see the technical breakthrough is coming up, and if you then the next level, if you see the what are the elements can be used for the power conversion architecture, those are the passive elements, power packaging components that will be there next. So that for example, if we are processing the power, still we are dependent on the passive element, energy storage element, capacitors, magnetics. So high temperature capacitor is much more prominent to reduce work on this area. magnetics, planar magnetics, enhanced cooling of the power converters, low strain inductance, packaging and assemblage. So these are the elements and packaging point of view. And the third is the advanced control and computing. So digital power conversion, we know it gives the ease of the operation in terms of the power quality and lot of things. We cannot go in details, just it will give you the idea. So it will basically, the idea is to advance control and computing. Multi-mode control techniques with advanced SOC. SOC is again the big area, silicon on chip. So if we have very good control on the design architectures, elements, and the devices, we can develop also the SOC. This is also the trend is coming in the market, and it is very silent. For example, if you see the Tesla and all, they develop their SOC by the help of VLSI companies, and their products is cannot be means cannot be taken by someone. Basically, we protect our design things. Then the wideband devices, basically we are talking today. So that is the high temperature operations, more compact products. Here in this session, we will discuss on that. So if we see the market outlook of the different products available in the market. So again, consideration here is in terms of the devices. If we see here low voltage MOSFETs, super junction MOSFETs, so we will not go in much detail of that what is super junction MOSFET. So just focus area is power processing as well as the switching speeds and the efficiency, size. So if we see here, this chunk of products are still under the category of super previous generation MOSFETs or the switches, basically that is silicon. So again here super junction is keep on evolving in terms of basically again it is on the verge of the limit, but it gives the higher efficiency. And if you see the EV and hybrid electric package, GaN and silicon carbide is crossing each other at the some fronts. And basically this will give you the idea what kind of market is moving in terms of the voltage range and in terms of the power range. If you see the rail tractions, steel, that is the very high voltage, high power, steel thyristor and IGCT driven. And EV, we know the voltage range is again there is a lot of cross things. Some places I have just made this to understand with. So there is a lot of things. Again, if you see the silicon carbides and GaN, here it is the cross. We will see that part where these things are there. So just coming to this part, what is the wideband devices? That is overview point of view. If we see the theoretical perspective, so these are the parameters: electric breakdown field, thermal conductivity, electron mobility, saturated electron velocity, and energy gap. All has the major, you can go to the theory, you will very much understand that part. So if we see the silicon is working here. So it has the capability to, in terms of if we just see the silicon carbide and GaN, so they are very much upper side. So they have very good thermal conductivity. So you can go with temperature can go up to higher level. But again, if you see here electric background field, so at higher voltage you can operate. If you go in your basics of engineering, if you operate at the higher voltage and lesser current, you will get the better efficiency benefits. We know that part, we will not discuss much things. Electron mobility also, they are upper hand, they have the upper hand. Silicon carbide is upper hand even with the GaN. So basically this picture will give you the idea, and it is also keep evolving. If we see here, we are on silicon carbide and GaN, still new products is also coming up. Diamonds, GA203, aluminum nitride. So a lot of things are coming up in terms of the voltage, in terms of the on resistance reduction. We know that, but if on resistance is less, you will conduct more current and less loss. So this will give you the idea. So besides, if you see here, besides GaN and SiC, other materials are also keep on coming. So now the discussion topic today's for us is GaN. So now coming quickly on the GaN transistor part, what are the characteristics, motivations, limitations, equivalent circuit, gate drivers, integrated solutions, package selections, lot of things. So I think the last section we have just summarized the first section. So there we have clearly identified the application needs where we can fit as engineers and where we can focus on the design and why people are talking on the wide band gap devices these days and what are the benefits on that. So and also we have also understand the market outlook, what are the markets and where they are moving in terms of power, current, voltage and all, where are the technology moving. Now these sections, hope last section is clear to everyone. Hope I am audible to?
Yes, sir. You are audible, sir.
Yeah,
Yes,
yeah.
sir. It's perfectly.
Yeah. If you find any difficulty, you can say that. Okay.
Okay, sir. We'll remain.
So yeah, sure. Now coming to quickly on the GaN side. So here, if we see the device characteristics, you can see here clearly there is no diodes, body diode here. So that's is the benefit. We will not go in much detail of that. What are the bottleneck of that and what is the benefit? Some places in converters, they are also the useful. But here we will talk about the benefits. At the end, we will also understand what are the negative part of this technology. If you see here, GaN can be grown as a standard silicon wafers. That is the very important point. That's why I'm reading this. Earlier, the problem was if you know, still we don't have the any means silicon manufacturing means fab in India. It is a very big investment. So if we made the things and large investment, and if technology is changing, for example, in LED, earlier we are in gas discharge tube, and semiconductor came up the picture. So lot of hinge in the market, in European market, because there are the big investment in the CFL and that on that days. And they are asking if we are going with new technology, then we need the support from the government, and they want the investment back, whatever they have invested in the for the development of the technology. So here the good part is the same means fab can be used for the GaN. And as I said, QRR is 0. So if QRR is 0 means no body diodes, so you will get the benefit of the efficiency. We will see that slide. I have also made that slide. Then we need also see the lower gate charge. So gate charge, if we go to the theory of MOSFET switching, so gate charge play a major role. So if lower the gate charge, you can you can allow fast switching, and that is very well known. People know that as a power electronics engineer. I think all are masters and PhD in this lecture and industry people. So if we know that part, the lower gate charge means we can allow the fast switching. If you allow the fast switching at the lower driving losses, you will get the benefit of the size and efficiency. At the same time, VGS-TH is lower side. Here some, for example, it is benefit. I am showing here the benefit. It is also some places disadvantage. And again, the much lower COSS, allowing a fast switching with, if you see the model, you know, if you go to Robert Erickson book, they have made very beautiful model of the MOSFET. So COSS also play a major role, and it will create the fast, allowing a fast switching with a Lower dead time. Lower dead time, you know, if lower dead time, if you are working with some converter which has the means like full bridge, half bridge, and phase shifted, that will create the issue. Dead time creation we have to go with, and better on resistance than silicon with higher operation frequency. So these are the benefits in the favor of silicon GaN devices, and that creates the motivation. So what are the motivations? If we see just by calculation, if we increase efficiency by 1%, you will get the 52% of benefit of power density. Again, your design will be simple. If you see the small size, efficiency will be high, and even at the hard switching topology, if you have worked in your simulation and you that design part, you know the drawback of the hard switching. But here we are getting the benefits. For example, PFC, continuous conduction mode PFC, they are very much prone to the hard switching. Again, if you go with the multi-mode, so multi-mode means DCM, CCM, continuous conduction mode, discontinuous conduction mode, or critical conduction mode. So again, you will be go in the different kind of switching means states. So by using this device, you will get the benefit of that. So you here basically idea is to they allow the hard switching with lesser loss, and efficiency curve is flat. So you know that if you are going with higher temperature, less thermal problem. So again, heat sink you can remove. Other lot of packaging things. Basically, means volume and weight will be less. So overall system cost will be no less. You know that part. If you people are also talking in China, they sell the products in terms of the weight in power electronics products. So this kg of this price. So you know that that is low system cost. Always trade off between efficiency and switching flow. This is not a new things. This is again, if you I have made put this as a means a point for the designer. So if we read the transistor data sheet, so we cannot follow blindly basically. So unrevealed something unrevealed in data sheet. They put the this current, this voltage for the MOSFET, but in the condition of 25 degrees Celsius. So that benefit you will never get, and that should you should aware being a designer. Testing environment is deviated from the practical operation. You know very much that. Offset caused by the testing equipment. Again, the equipment is very important for the designer to testing purpose, because if you are going to much higher switching frequency, you have to needed for the new kind of equipment for the testing purpose. Unoptimized layout design. So these are the points we should have to be motivated by using this GAN. Here I have just put the reverse recovery charge benefits. Here GAN, silicon carbide, and silicon, all three are there. If we see, I think this graph everyone knows, even in the third year of BTech. So this QRR play a major role in terms of the efficiency reduction. So if you see here, GAN is very almost negligible QRR. So the absence of QRR makes GAN devices suitable for hard switching topology. So you can allow hard switching by using these devices. So this will again not only that switching loss benefit, another benefit is the EMI. I think if you design your product, you put in the market, you should have to follow the norms. So EMI, EMC play a major role. Even your product is ready, you cannot put in the market because you have to pass EMI, EMC certification. So if you have to reduce the design cycle, you know that if you are working in consumer, design cycle is very less. Even everywhere design cycle is less. Within 3 months, 4 months, you have to design your new product. So you have to keep in mind the EMI and certification part. So this basically GAN will be helpful in terms of lower EMI, and it will give the benefit. You know that ringing part and all. We will not go on detail of that. And the power loss calculation, if we see the conventional MOSFET, if you see here, switching loss, I have just taken few examples and calculated for your this discussion. Switching loss is 20%. Conduction loss, here if you see, 25%. And power losses from other circuitry is more. And if you transition from the conventional MOSFET to GAN MOSFET, you will get the benefit here. Power loss from other circuitry also reduced because you are reduced the volume, and materials weight, power saving is more. Conduction, this is the basically the idea. It is all depends on how you design your products, and just this will give you the some reference and point to understand it. Now quickly coming to the limitation part. What are the limitations we have? Every technology has the limitations. I have taken some things. If you see, no avalanche breakdown, I think this is also a very important part. What is avalanche? Normally what happens in the conventional MOSFET, like as I discussed in silicon MOSFET, they have the high avalanche. High avalanche, basically it will help in when you are working with some search and other things. So avalanche is, there is no avalanche basically in this kind of devices. So you should know that part. And poor short circuit performance. So even if you have to design your product, you should have to go with this protection part. So poor short circuit protections, these are basically means in relation with others. Reverse voltage is high, so some places it will be is
Hello,
a,
sir.
yeah, correct,
Am I
yes,
audible?
yes.
Sir,
Hope I am
actually, in one slide,
correct.
you mentioned that 1% reduction in loss will 1% increase in loss.
Correct.
That increases the volume by, I think, 50% or something like that. It was there.
Yes.
52%. So, sir, this increase in volume is mainly due to heat sink, or some other factors are also involved?
Other also involved. If you see here, na, so in that's why after this slide and this slide I have just put. So this is the power loss from other circuitry also play a major role. Okay. So okay. So I will give you those brief also at the later slide, the size, benefits, and those are the things. Okay. So like for example, if you use the high switching frequency, the passive device size is basically inversely proportional, directly proportional. Means if you frequency is more, your capacitor size will be less. At the same time, your magnetic size will be less. So overall benefit you will get. Okay. Hope
Okay, sir.
you are,
Okay.
yeah. So again, heatsink will be less. So overall system size will be less. So you are also getting the benefit of kilowatt per kg, kilowatt per liter. Okay. So as well as the volume, as well as the weight. Okay. So that's why I have discussed in the initially what are the talking points for the business. Dollar is the talking point for the means the shipments, purchase, planning, kg weight is the important factors, and
Mhm.
for if you packaging, for example, if you have made the product, you have to sell in the market. So packager will ask you what is your volume. They will charge accordingly.
Correct.
Okay. So these three are the major talking point for the outside world for the designer. So if you expose to the outer environment, they will not ask you what is your design. They will ask their data points. So for marketer, data points are the cost. You know that part very well. So they have no bother. Are you working with GaN, silicon carbide, switching frequency? That is your work. As a designer, you should aware, and your team will should aware. For the outer world, that is maybe if you talk that part, they will think you are discouraging them or you are putting them some other dynamics. Okay, so that's why. So that is our topic is to understand the technology, but their topic is to understand the cost, weight, volume. Okay.
Yes, sir. Thank you.
Yeah, thank you. Welcome. So means now coming to the topic. Hope it is linked. Topic is linked.
Yes, yes, sir.
Okay, okay. So there should be no diversion in the discussions. Otherwise, we will break the chain. So question is welcome. You can ask in question in between. That will be more effective for the lecture. But also we should not break the chain. And so now after the benefits, now we are talking on the limitation part. So limited safe operating, just a minute. I'm just taking the highlighters. Okay. Safe operating area. If you have to read the data sheet, you should very much understand the safe operating area. What is the safe operating area for your product? Even if you buy the means AC source, electronic loads and all from the market, they put the safe operating area for their product. Similarly for the means devices, it is very important. So if we see here, the in verge of in comparison with the conventional MOSFET, here the limited safe operating area, and you know the power processing is more and size is less. So package not easy to handle. We will discuss that part. So this is the limitations coming for the GaN. So under other shortcomings in a constellation manner, if we see the high frequency and high dB by dt make circuit with GaN sensitive to layout. You know that part people also talking, if you see the older generations, they are also talking, they, they are also telling basically the GaN and the wide band gap devices creating a lot of confusion for the designer because their thought process are different. They are early generation, they are thinking dv by dt create a lot of issue. So high frequency, sometimes if you see the maybe Professor Cook lectures, they are talking like that. So high frequency and high dv by dt makes circuit with GaN sensitive to the layout. So layout design is very much important. So being a designer, you should also focus here. So design, even your design is okay and architecture is okay. If PCB is not good, so you will be not able to get the output. And due to the lower driving voltage and the max value, typical plus 7 voltage, precise VGS regulation is needed. So gate driving is very much important. So very precise gate driving circuitry is important for the GaN. So it is coming for the shortcomings. If you had the, for example, in early generation MOSFET is separate and gate driver is separate. But here it is very important. You have to design a gate driver in such a way so that it should be precise and less prone to the means dv by dt frequency and that. You know that part if you, but you should have to take care. GaN has a lower heat conductivity than the SiC. Here I am just made the comparison between silicon carbide versus GaN. So here basically GaN has the benefit some places, but here in terms of the SiC, they have the lower heat conductivity, and they are not drop-in replacement for silicon device. This is very important point. You cannot change directly silicon circuit, silicon MOSFET circuit with the GaN. For example, if some product is already in your market and you just change the component and run the product, that is not possible. So it is very important point. So if you are working with the previous generation MOSFET and you are coming with the GaN, so you should understand that part. They are not drop-in replacement. Okay. So other critical aspects are probes connections. Again, here you have to need new kind of probes. Device paralleling also play a major role here. It is not easy to parallel GaN MOSFETs because due to the very high switching frequency. Minimize power loss, loop trace. Again, this is the point of view of the PCB design. So these are the basically shortcomings, but it is the overall it is the beneficial because you are getting the other benefits. Now coming to the equivalent circuit in convention of the silicon MOSFET. So if you see here, the right side is the conventional MOSFET and left side is the GaN. Enhancement, high mobility, means EHMET. It is basically known as to not create confusion in relation to the other GaN devices. Okay, so this kind of GaN, they have the benefit. If you see here, see in off conditions, this is the change. So that's the reason it can be operated in the third quadrant also. I think you know that quadrant of operation of the switches. First quadrant, second quadrant, third quadrant, fourth quadrant. It is good if your one device can operate on all the four. So that's the benefit with the means again it can go for the third quadrant as well. So this slide I have just made clear to the gate driving point of view. So gate driver is very important and it should be integral part of the driving the means GaN. So if you see here, the maximum voltage limits for VGS of enhancement mode GaN device are around -10 to +7. I already discussed in last sections. So exceeding these limits may permanently damage the device. So that's why if you see the silicon means manufacturer, they provide GaN with integrated means gate drivers because they don't want to fail their product in the market. This is the reason because it very specialized and permanently basically if your gate driver is not work well, your MOSFET will fail and you will see the product failure. The control the Miller effect, I think you know that part. Miller effect during the high negative DVDT, the gate must be held on with a lower impedance path. So basically that's the reason I just sorting this discussion. So if you see here, this is the model of the conventional. You see here. So here you will conventional and this is the means a GaN based driver. So that's the reason these are the basically conventional kind of things, and that's the reason we are going with the integrated solution. For low and medium power applications, we embed the things. If you see the product in the market, if you go in any silicon manufacturer GaN devices, they will supply the GaN driver with integrated with the gate drivers. GaN with the GaN devices with the gate driver. Sorry. So basically, smart features can be integrated as well here, like under voltage lockout, over current protections, interlocking. Okay, so if you see here, last in conventional, if you see this kind of, this switch is turning on, generating the half bridge DV. This is a half bridge solutions, half bridge circuit. And here you have integrated everything so that you will get the benefit of that. But you should understand, if you have chance to work in application engineering in some semiconductor manufacture company, so you should have to understand these kind of architecture. So that the other points we discussed, the heat dissipations with package. Basically, these are the different packages available for the GAN. If you see power flat, PQFN, 2S pack, power flat pack, these are the naming. So the cooling point of view, if you design your PCB, so you have to think about how you cool the device as per the need. So heat dissipation with package will give you the idea. Even if you read the data sheet of the GAN, you should understand that part very well. That's the reason I have put here. So in bottom side, if you see, the cooling, the heat is brought through the thermal vias. Thermal vias you have to put, so that I think you know that part. Just I am highlighting this. So thermal vias, basically what we have to do. Three mode of, means the conduction, convection and radiations. So if you go with means the forced cooling, then that is separate things. But idea is to go with first on the natural cooling. So on the PCB you have to either put the vias, you have to thermal pad and all, so that you will get the benefit of that devices. So this will give you the idea in terms of, like if you see here, heat sink and tin, so that tin will create the conduction more, and it is the PCB, so you will get the better cooling. So in this, now closing the second section, so on that part we discussed about the benefits, not benefit, the actual use case of, you see here, GAN transistors details. Okay, so I will not conclude, just concluding that part, that basically the benefit, use case, shortcomings, equivalent circuits, gate drivers, integrated solutions, heat dissipations. So in summary, in first section we did understand the technology, in second section we understand the devices. Now we are coming to the benefits part. What are the benefits, application benefits with examples? So I've just taken few examples to show the benefits of the GAN devices. First one is the hard switching. Hard switching topology benefits, I think hard switching everyone knows in your Nedmohan book or any fundamental electronics, power electronics books. Hard switching means there is overlapping of the voltage and current, so that loss will be more, and we have to avoid the hard switching. But in this technology we can go with hard switching also if it is very much needed. So why it can be useful? Because here we have 0 QRR, the lowest QoS and QG allowed to gain efficiency in hard switching topology. So especially in CCM, bridgeless totem pole PFC, because you know, if you have to go for the resonant and soft switching things, you have to put the extra circuit to ensure where voltage is there and where current is there, so that you can create zero voltage or zero current. So it will create other control difficulty and design complexity. So that can be avoided, and you can allow that also here. So hard switching topology. So here you will get the higher efficiency due to the lower switching losses, higher power density, lower THD. So already you know that OBC onboard charger and PSU, they are already in use. And just I have given you the highlight of what is the hard switching. So again here loss is less because due to that, so you can allow that. In synchronous boost converter, this is another example. I think everyone knows what is synchronous. Synchronous converter, if you work in the flyway converters or any diode driven converters, so at the some time, if you, for example, if you see here, so if you put here diode, So there will be the fixed on loss and fixed on loss, and at the sum time at the, if you go in calculation part, at the sum level, if current is more and voltage, output voltage is less, for example high voltage and low voltage and high current converters, then we have to go with synchronous converter, otherwise diode will create lot of loss and other limitations as well. So for overcoming that, so we have to go with the synchronous converter. And so synchronous converter, again, if you know that, if you have to put the some MOSFET here, if you are putting the MOSFET, you will, loss will be more. So if loss is more, again you know that, so that is the benefit here. So if by using the GAN you will optimize the design. Even in soft switching you are getting the benefit of GAN. This is the example of LLC converter. You know that this is the extra circuitry, as I told you, CR, LR and LM. So this circuit, this kind of arrangement you have to make for designing the LLC or soft switching converter, so that you will get the idea when switch is going to be off and when we have to on the switch or off the switch. Otherwise, basically idea is to switching loss to make zero. Even we have the very less Q, RR or other, even that benefit you are getting by using the soft switching topology. So basically if you see here, GAN enables better soft switching performance, especially in resonant converters. I'm just reading that to understand basically where higher switching frequency and lower dead times. So here we are getting the benefit of dead times, because if you know, these two switch has to operate. When this switch is on, this switch has to be kept off, and when this switch will be on, this switch have to be kept off. So there should be some dead time, so that there should be no cross conduction. If at the fraction of second, if there should be the microsecond cross conduction, then you will get the dead short and your device will be fail. So that's the reason dead time is there in conventional MOSFET. That time you have to put significant, because they have the COSS value will be are significant there. So you are getting that benefit here. So I think you remember that way we are going with the single switch to double switch, triple switch, due to the higher power processing, better control, lower the means passive element size and all. We will not discuss that part, but idea here is to, here benefit is the dead time is the less, and you will get the better power conversion. And if dead time is less, again the benefit is reduction of the EMI. Okay, and already that can be in use of power supply units, server power supply and onboard charger and all that. Lot of applications are there, even in LED drivers as well. Adapter applications, if you see in adapter, you know, again the flyback converter you have seen here. If you design active clamp flyback, you will get the benefit of higher efficiency. That is again the obvious things. People know that active benefit of active clamp. A lot of papers in the literature. This is the passive, snubber is there. You have the active clamp. So snubber loss is optimized here. So using the GAN, you can get the benefit of that. Okay, so in adapter market, that's the reason new adapters coming, GAN based adapter, they have the very small size and higher efficiency and high power density, lot of things, RCD flyback and active clamp flyback topology. Again here also, if you change the diode with the synchronous, so that benefit you can get. So this market is very, you know, that is very wide good market, and it is lot products are means volume is very high. So you will get basically the benefit here is volume. Basically this market is volume game market. Okay, so this design will help you to optimize the design and a small form factor.
Sir, actually, sorry for the interruption. May I know the cost effective of the this device? So, what would be the cost?
Cost, basically, as a designer, we cannot focus on the cost part
Cost,
because
okay.
because problem here is cost game is completely driven by the volume, and means problem here is if you have larger higher volume, you can discuss with manufacturer, semiconductor manufacturer, they will give you the lower price. Good part here is if you have put the GAN, you have reduced the other parts, passive elements and other things will be less. So
So,
your focus area will be there, and price is definitely, that if new technology is coming up, so price will be higher side. But other components is not there, then that will be the reduction. And
so
again,
what would be
if
the
you
difference? Means approximate difference in between that conventional device or maybe converters, whichever we are purchasing, and then
4x,
so
4x. If some products available in the adapter, if you go in the any web page of any GAN, like GAN systems and other even in TI and other lot of company, they put their product on their web. So size is almost 4x reduction. So volume is reduced, size is reduced, and that's why you get the benefit even you go with higher temperature. Okay, and if you have very good supply chain, you reduce even price also. People are claiming price, they are also getting the benefit of price as well, because if volume is more, and you know that silicon infra is same, means wafer infra is same, if requirement is more, so they can reduce the price. Okay. So
thank
even
you, sir.
GAN charger in, if you see, you go to the GAN system web page, you will see that charger and other like this adapter price is overall price is less. That's why they are designing now. Because if you go in any industry, there they will do first benchmark. They first focus on the price front. Okay, so
Yes.
that's why I have put second slide there. Dollar is the first talking point. So they first benchmark that part. If price is more, they will not go with that business. And if this business is coming, definitely they are getting the benefit of the price. Okay.
Thank you, sir. Thank you for the
Thank you.
information.
Thank you. Thank you. Thank you. Again, totem pole PFC, I think this is again a talking very much talking point. So it is also known as the bridgeless topology. So in bridgeless, if you see, you have removed the diodes with the MOSFET. So I have just taken two MOSFETs from the GAN, two MOSFET each from maybe conventional. So you can get here as well as the benefit of the totem pole PFC here, lower bomb count. As you ask these questions, bomb count is less. So if you go in the management side now, so what happens if bomb count is less? They have much bargaining power with the vendors. For example, if your product have 15 components on your board, and if reduced to 10, then your supply chain has flexibility to discuss with only 10 vendors. Just example. Okay. So idea is to reduce the BOM count so that supplier or your means supply chain team will discuss lesser vendors, and so that you will get the benefit of the price. This is completely electronics, is completely volume game and very good supply chain management. If you have very good supply chain management and high volume, you will get very lesser price and you will sustain in the market. But that is not our discussion point. Our discussion point here is to focus on the technology. Okay, so we cannot go on those details. That is the maybe the management side. If we have some chance to discuss on that part, so we will put some lecture on that also. That is supply chain management, positioning of the products, and that is a different game. Okay, so topology enabled GAN and SIC not possible with the silicon. Okay, due to hard switching. If you see, I already discussed that part. Hard switching, it create a lot of issues with the silicon, conventional silicon. But here we can get continuous conduction mode is possible even in hard switching with the GAN devices. Bidirectional topology. This will give you the, basically if you see this picture, this is average mode control techniques for the power factor correction. You know that part. If you are designing your power converter of more than 500 watt, you have to go with the average mode control technique. You should not rely on the transition mode or discontinuous conduction or so average mode control techniques. This picture will give you the idea. So inductor current, average current control, and CCM. So here you will get the benefit of using this. LLC resonant DC-DC converters already discussed. This graph I have just put here to understand. You know that if anyone has designed LLC converters, there are different zones, capacitive, inductive zones. You should not go in the light loads, heavy loads, depends on the zones, and accordingly you have to optimize the switch. Okay. So LLC resonant converters or any resonant converters, DC-DC convert, normally LLC is there, even people are talking on LCC converters, lot of things are there. So here you will get the benefit of GAN devices. So what are those benefits? If you see here, lower gate driver loss and turn off losses, so FS can be increased. FS means switching frequency will be increased. So if your switching frequency will increase, so what will be benefit? With a higher switching frequency, ILM peak, ILM RMS decreases. Then conduction losses are basically you will get the benefit of conduction losses are also decreased. With a lower RMS current, the power density can be increased, reducing the size of magnetic component. This enables the use of planar transformers. Again, this is a separate topic. Planar design is again good big area. So planar magnetics is also coming up, and people are working. Even design is available now. So planar magnetics play a major role in terms of power density. We will not discuss here that part. So however, magnetic component losses, core losses and winding losses are increased with a higher switching frequency. So you have the losses will be more, magnetic losses, but overall you are get the benefit of that. So GAN enables the shorter date time, as I discussed earlier also, than with the silicon due to lower COSS that will increasing the efficiency. So dead time loss, I think if you have designed that part, it is very much significant. So you will get that loss, and here you will get the benefit because lower the shorter the dead time. And as you ask that question, that is very good questions. So 20% of loss reduction compared to the silicon based solution, or 1.7 times a smaller size with the same efficiency. That is the benefit people are claiming. But it all depends on your design and thought process, but it is available. You can get the products available in the market. If you design the things, you first benchmark the things. If product is available, you go through and understand first, and then you design your product. Now that is the last slide in terms of the benefits. I think we have captured different perspective that are hard switching. We discussed what are the benefits of the hard switching, synchronous converter, soft switching, adapter products, totem pole PFC, LLC. So basically if we summarize here, so hard switching benefit you will get in the PFC. Synchronous converter you will get the benefit of the low voltage, high current, maybe the mobile and products and small charger, low power charger. Basically low voltage even in chip designs, or maybe I think you know that part, uh, point of load converters. So those kind of converters are mostly prone to the synchronous. So idea here is if your voltage output voltage is less and current is more, you have to go with synchronous. Soft switching already we discussed. Adapters, you already, adapter is mostly flyback converters. So flyback converter you will get benefit of active clamp as well as synchronous. Totem pole PFC, that is already we understand that part. What is totem pole PFC? Totem pole bridgeless basically, and LLC resonant DC-DC converter. So these are the 6 examples, and that could be many more that you will get the benefits by using the GAN. So that was the conclusion of third sections. So first section basically we discussed about the technological front. What are the products? What are the things we have to work for? What are our design strategy, and what are the market we have to go with? Then we quickly discussed on the benefit of wideband devices in the first sections. And the second section, our idea is to understand what are the GAN transistors, what is the differences between GAN in terms of the power electronics designer. And the third section, we get the benefits of the basically using the GAN in terms of the design circuits. So we have taken the different examples: synchronous converters, hard switching, PFC, LLC, DC-DC converter, and others. Okay. Now coming to the last sections, here we will discuss about the what are the sources where we can get the GAN devices, where we can source, or where are the vendors they can supply you the GAN devices. Then quickly we understand the where are the applications, what are the applications area for the GAN, not for the complete power electronics that we have started in initial. What are the applications area where you can your GAN gallium nitride devices can be suited. Then we discuss about the GAN potential products. What are the products available in the market? As you said, what is the price? So price is very much important. So without price benefit, business will not run. So if product is available in the market and it is selling, and selling concept is there, so definitely we can focus there. So business will focus on the products and benefits. Okay. So then we will go with what are the GAN potential products available in the markets. Then we see the different means products available, as well as also understand the other products like lidar other than power electronics, lidar applications, audio and amplifiers in these sections. Okay, any question first 3? Hope I am audible to everyone.
Yes, sir, you are audible.
Yeah. Okay. So here means we will start. So what are the commercial available GAN devices? If you see the market here again, you know that voltage point and current. So mostly still if you see the mostly are up to 650, 700, but it is keep on changing. So these are the manufacturer: EPC, GAN system, Panasonic, Transform, On Semiconductor, Texas, Sanken, Extragen, Visic Technology, Dialog, Navitas. I think I missed few. ST is also there. ST Microelectronics. So a lot of commercial available GAN devices are in the market. So that's why it is not new now, and the business is there. and it is just I have put this as in terms of the voltage and current, but this is not fixed, it will keep on changing and evolving. So up to 12 volt, 1200 volt and around 50 ampere current devices are available, but it is keep on changing. So it will give you the idea and go through those web page and understand their application and what are the products and the application circuit. Navitas is also very good player and they have also good designs. So a lot of designers, I think a lot of semiconductor manufacturer available in the market. Now coming to the target applications where we can focus GAN here, like in industrial, you know, the solar power supply unit for industrial drives, motor control, in telecom, power supply for telecom, PSU, power supply for the servers, data centers, in automotives, onboard charger, DC-DC converters, LIDAR, charging stations, in consumer, charger, adapter, USB PD, consumer electronics, power supply, consumer electronics power supply. So these are the target applications for the GAN. So this sets will give you the products available in the market. So in lighting, it is there, laptop chargers, indoor PV inverters, medicals, wireless charger. These I have just taken this as a reference for representation purpose. Audio amplifiers, if you see here, EV, hybrid electric vehicles, these are the products available in the market, different RF power applications. Okay, so these are application products. Now coming to next level. So for example, motor control, if you see here where GAN can fit. So low inductance and high speed AC or DC motors, servo motors, drones. I think drones, you know, that is now talking point now, can have benefit in increasing the switching frequency in the range of this. This point means if your switching frequency will increase up to this range, 40 kilohertz to 100 kilohertz, you will get benefit here. Servo drives, drones, etc. Increasing the switching frequency, the phase current ripple is reduced. I think you know that part. So your if frequency will be more, then phase current ripple is reduced. If current ripple is reduced, the motor losses will be also reduced. Temperature of the motor can be decreased. Bus capacitor can be reduced. Better control, current control. So here also in motor control, you will get the benefit of this. Also increasing the switching frequency, the efficiency is higher due to the GAN performances. BLDC motor control, I have just taken 1.5 kilowatt product available in the market. So this is for your reference. You know that this is very much known for you. So electric motors are everywhere, estimated to consume more than 40% of global electricity. This is just top points. So here you will get the, even in BLDC control, you know that what is the BLDC and what kind of MOSFETs are there and how you can design or change conventional MOSFET with the GAN. So again, you will get the benefit of lower heat size, smaller size heat sinks. Okay, and you know that BLDC works on the square wave, so that generations you will get the benefit. Again, for higher PMSM also you can work with. This will give you just a idea. So BLDC motor control is the area where you can use the GAN to reduce the size of your motor driver. Okay, so wireless power transfer, I think you know that. So it is time to cut the last code connecting our devices. So already mobile phones everywhere people are talking for the means no wide connections, and it is basically ease of convenience. So now people, if you see, there are a lot of groups, they are talking about it is time to cut the power cord. So it is not easy, but it is coming up. Even wireless power transfer is the technology people is talking much now. For the academics, this is a much talking point. So here also you will get the benefit of using the GAN. Using this device again, you will result in wireless power system that provides the same level of power as the wired system. As you- So this is again a product available in the market based on the GAN. Okay. So traction inverter, you know that motor control is for maybe even if you see the EV market is not only car. There are other e-rickshaw, electric boats, lot of things are there. It starts from maybe electric cycle. It starts from even for 200, 300 watt to higher than that. That we know that electric traction inverter. This is an example I taken from somewhere. So they have developed the GAN.
Sir, sorry to interrupt you.
In,
I think
yeah,
your audio is a little bit breaking, sir. I think others also getting,
okay.
sir.
Just my network maybe is- it okay now?
Yes,
Now
sir.
it's
Now it
fine.
is fine.
Now it's
No, fine, sir.
Not okay. So screen is coming to you? No.
Coming, sir. It is coming, sir. Please make it full screen.
Sharing is there. Just a minute. Is it okay now?
Yes, sir. It is okay, sir.
Okay. And
Thank you.
voice is also clear?
Yes, sir. Clear, sir. Clear, sir.
Okay, okay. So traction inverter for EV application, you know, normally in electric vehicles, as a power electronics engineers, so engine is the motor, you know that part. And earlier engine, you know, IC engine and all that's are keep on changing, and now people will go in near future motor as a engine. So for driving the motor, you need a traction inverter. So that traction inverter is very much dependent on the MOSFETs switches. And for that, again, GAN devices is very much useful for them to reduce the size and reduce the weight, reduce the volume. And the motors in EV are powered by inverter, that is the obvious things. So here you will get the 5% longer driving range also. You know that part. EV is much talking point. So there are three major focus area there. So larger distance, better charging points, means battery and all. We will not discuss that part, but here as people are claiming traction inverter by using GAN, you will get the 5% of longer driving range and a smaller size and all. Here also DC to AC inverter. Basically DC to AC inverter is there already, but DC to AC or traction inverter can be designed, because traction inverter, you know that part, the reverse and that is bidirectional and a lot of things are there. So that kind of benefit you will get. And EV charger, you know that that is very much talking point. Onboard charger and charging infra is obviously is not for the GAN, because their charger is a very big size, or maybe big, not big size, big higher power level, so their silicon carbide is much talking point. But onboard charger, even I have highlighted some pictures I have taken from the web. So these are the products available in the market. So here using GAN results in onboard charger that are lighter and approximately 1/3 of current size. So whatever the current size available in the market, it will get benefit of 1/3. This contribution both to decrease the vehicle weight. You know that in the car, battery weight and charger weight or any weight, extra weight out of the, in conventional car, their engine weight is very high, so that's why they are there is the limitation on the mileage. So they, even no one is on the car, but they have some weight. But in electric car, the weight constraint is mostly focused on the battery and OBC, onboard charger, or motor driver, basically the in traction inverter. So onboard charger weight is reduced, as well as size will reduce. So these are the some benchmark product available in the market from the few company, Hella and some others, Continental and all. These are in public domain, so we can show that that is not issue. So DC-DC converter are the vital in electrical and hybrid vehicles to bridge the high voltage battery pack with the low voltage auxiliary circuits. So again, the DC-DC converter, you know, a lot of DC-DC converter in use, still it is there even in conventional vehicle. So that, but if you are going with the EV, so more DC-DC converter will be there. GAN use case results in DC-DC converters that are highly efficient, reducing the loss and wasted power to heat. This is the obvious thing, already we discussed a lot that. Even in portable power storage, like for solar power storage, again this is a product available in the market. They have portable power storage. You know that if there is a sun somewhere and you open your EV, basically your portable power storage, so obviously your charge, basically power station is sorry, just I'm taking these pointers. Okay, so this is your means power station, and you will get the charge by using some converters, that is 500-watt portable power storage. You can focus here. This is the good product available in the market. And from tranquility of outdoor camping, retreat the scenario, disaster emergency relief. You know, some, if some hazard is there, maybe flood and some places, you know that power outage is the obvious things. On that case, it is very difficult to run something. So solar power storage is the obvious choice, and that can be if weight and that benefit. You know that solar charger is normally the main pain point is the size of the panels, battery and all. But you know the battery is also evolving and the panel efficiency also keep on increasing. And at the same time, if your converter size is also reduced, so it could be used as a portable power storage, and that can be and the GAN will help you. And already product is available, and you can focus and start your design on this line. So using GAN results in your power electronics that are smaller, lighter and more efficient. So this kind of product you can focus, maybe 300 watt. Also, you know that at least lighting in home as LED is there. So 100 watt is the maximum for a home of maybe a 2000 square feet area. You can up to 100 watt is the maximum for the lighting load. So at least you can light up your area by using this kind of portable power storage. Again, the benefit with lighting is they are DC, so LED is DC. So that kind of thought process will be there. There even in mobile charging, a lot of things. Basically, this will give you the idea. Okay. So another application is the lidar. Lidar, I think you know the conventional lidar. I think you know that part. What is the lidar? Light detection and ranging. So that is for autonomous vehicles. If you are working, then that kind of things people are thinking. So earlier it is dependent on the silicon. As GAN is evolving. So people, basically designer is now focusing here. So basically LiDAR are used to create 3D image of the environment, evaluating the distance using the pulsed laser time of flight measurements. So normally for LiDAR application, basically LiDAR and radar, you know that part. LiDAR is the most stopping point for the autonomous vehicle people design. So GAN will be used here to drive the laser source. So laser source is the major power source for imaging and detecting the signals. Basically, what LiDAR will do, they throw the laser light and then it will come back, and based on that the image processing. Again, there is the one more area coming up. The means for power electronics engineers, that is for video processing for power electronics and all. So image processing. So in that sense it will be more useful. GAN can be used to drive the laser source with higher current pulses. Means here talking point is, if your current pulse is more, you will get the very much clear vision, and that means vision you will capture, and based on that you will record and put the image processing. In computer vision, I think you know that computer vision application of the power electronics, that kind of area. So that computer vision you will get better by using the GAN. So the higher current allow LiDAR to see further, while shorter pulses increases the image resolution. Already I told you. So better image capturing, better decision in terms of the LiDAR. In class D audio amplifier, you know what is audio amplifier. Now I am just moving other sides. So in even in LiDAR, so that is not for power electronics, but it is GAN application is there. In class D audio amplifier, if you see here, this is the idealistic waveform. It is needed for the audio amplifications. But it MOSFET switching waveforms, if you see the conventional, these are the noises. So you will get your there. You have to design some filters so that this can be isolated, removed. But using GAN, you can see here this kind of very small noise is there. Basically, the waveforms is very much because there is no body diode, so that kind of benefit you will get. So that benefit you you are getting here. So here ideal switching waveforms is this, but GAN is very much close to the ideal. So here also GAN enables a significant increase in the sonic quality. Sonic, you know, infrasonic, ultrasonic. Sonic means what? Sound is sound means frequency. You know that part. What the sound frequency band is there for that hertz to 50 hertz to 20,000 hertz. Between that we can audible. That sound is audible. That is under the sonic. So that sonic sound can be created ideal by using this GAN, and obviously if it is very much ideal, you will need very small filters and all. So in summary, not only power electronics, other area also GAN is useful. So now I think this was the last slide. Thank you. So in summary, I think all four sections is there. I think I captured the all four in this, and I think we have around 10 to 20 minutes for the question. So if you have some question, we can discuss. We started from I think application area, then the transistor use case, then benefits, then at the end the where it is already in use in the market, what are the market penetrations, already products are available, and at the last, not other than the power electronics like LiDAR and audio amplifier. Thank you for your time. Thanks. If you have some questions, you can ask.
The participants can interact with the speaker if you have any queries. You can unmute your audio and you can interact.
Good morning, sir. Myself, Shashank. What is the availability of gallium nitrate material and cost compared to silicon?
As I said in between also, the cost front is volume game, and we cannot claim on there. We cannot discuss that part. It all depends on how good your supply chain. And but if you see in the market, price is competitive. Overall product is it is not very higher side, but it all depends on your product roadmaps and volume and all. Okay. So, so that part I think we cannot discuss now because it is very difficult, na? Because it is volume things. How much, how many products you have to develop, what is your market potential, based on that price will be there. Okay, and it is evolving technology, so definitely it will come. So if some technology is coming and it is there is a market, so definitely it is the price front, it is okay.
Okay, sir. Thank you.
Mhm.
Any more queries from the participants, please? I think there are no more queries as few participants might have interacted with you during the session also.
Okay, no problem. Thank you.
Sir,
So
thank
much
you, sir. Sir,
joining with us.
Aman, yes, sir.
Yeah,
Thank
thank
you
you.
so much for your
Thank
valuable time, and so that too we are actually contacted you means very short of a duration. Still, you give an acceptance for giving that an expert lecture on really the advanced devices, and so of course it is very useful for future generation. And
thank
so
you.
thanks a lot for your nice presentation and so valuable inputs as well. Thank you, sir.
Thank you. Thanks for your time. Thank you. Thank you, team.
Thank you, sir. Thank you for
Thank
joining
you.
with us early morning.
Yeah, thank you.
Thank you, sir. You may leave the meeting.